All right, so George lifts the box and does 90 joules of work to lift a 8-kilogram box at a constant speed. If he drops it, how fast will it be when it hits the ground? So we have the potential, and well, first of all, remember that the work is equal to the potential energy, which is equal to the kinetic energy, because the energy can't be created nor destroyed. We lose a little to friction, but we're going to ignore that for now. So the work that he did is equal to the potential energy, which is equal to the kinetic energy. In other words, his work is equal to the kinetic energy. But remember that the kinetic energy is equal to 1/2 times the mass times the velocity squared. Okay? Well, the work that he did, they tell us that the work that he did was equal to 90 joules. So we have that 90 joules, whoops. We got the work that he did was 90 joules, and that's equal to 1/2 times the mass of the object times the velocity squared. And they're asking us what is the velocity, right? So I've just got to solve for the velocity. So the first step in that process, I want to get rid of the 1/2. So I multiply this side by 2 and multiply this side by 2. So now I've got 180 joules over here is equal to the mass. But they give us the mass, right? The mass is equal to 8 kilograms. So I'm just going to, this cancels. 1/2 of 2 is 1. So I'm going to type in 8 kilograms. And that's equal to the velocity squared. So the next step then would be to divide both sides by 8. These cancel. 180 divided by 8. Let me pull up my calculator. It'll be like a weird decimal. 22.5. Oh, this is easy. What is it, 1.5 or 5 or something? 22.5. And we'll just leave this as joule kilograms is equal to the velocity squared. So now what do I do to find the velocity? Yeah, let's take the square root. So if I take the square root on this side and the square root on this side, this becomes velocity, and then I just have to take the square root of 22.5. So if I say the square root, it's about 4.74 roughly. And remember, velocity is in meters per second. And remember, joules is like kilogram, meter square. It's like joules is like Newton, meters, and then newtons is like it ends up being like kilograms, meters squared, second squared, or something. So the kilograms on the bottom will cancel with the kilograms on the top, and then the square root of meters squared over second squared is just meters per second. Huh. That's a lot. Let me write that down so you guys can have a visual. Remember that newtons is equal to kilogram, because it's force times acceleration per second squared. Remember that joules is equal to Newton times meters, or joules is equal to kilograms meters squared over seconds squared. So when I say the square root of joules over kilograms, I'm really saying the square root of kilogram meters squared seconds squared all over kilograms. The kilograms cancel out, and I end up with the milligram, the square root of this And whenever you take the square of a square root, let me move my face. You end up with meters per second, which is what we have here. Okay? I know most of you